We reveal our next incredible Toyota vehicle. As most of you know, we've been working extremely hard to bring customers the most diverse lineup of vehicles in the industry.
Japan is about to unveil a game-changing engine technology that could completely disrupt the electric vehicle industry. Today, we're exploring how Japan's new innovation is set to revolutionize the EV world. This isn't just another tweak to existing technology, it's a bold leap forward. Could this new engine be the key to overcoming the major challenges facing electric vehicles today? The implications are huge, and you're about to find out how Japan's latest development could leave the rest of the world playing catch-up. The revolution in motion. Japan's automotive industry has long been recognized for its ability to innovate and lead in technology and reliability. From the introduction of the Toyota Corolla to the revolutionary Toyota Prius, Japan's automakers have consistently set the standard in automotive engineering. With global players like Toyota, Subaru, and Mazda, the country has earned a reputation for producing vehicles that combine cutting-edge technology with dependability. The latest breakthrough from these automakers is a new engine technology that promises to disrupt the electric vehicle (EV) industry, offering a practical, sustainable alternative to traditional EV solutions. By leveraging carbon-neutral fuels and hybrid powertrains, Japan's new engine technology is positioned to transform the future of mobility
into their next generation internal combustion engines.
Unlike traditional battery-powered electric vehicles, Japan's new hybrid engine technology can operate on carbon-neutral fuels, which can be refueled at existing gas stations, reducing the need for new charging infrastructure. This innovation presents a scalable solution to reduce carbon emissions without the need for a complete overhaul of current infrastructure. With 500-mile ranges, 250 horsepower, and refueling times of just 5 to 10 minutes, the new engine offers consumers the convenience and speed of traditional gasoline-powered vehicles, but with significantly reduced environmental impact. The ability to quickly refuel at gas stations makes this technology an ideal option for regions where EV infrastructure is still limited. Hybridization of powertrains is by far the most important new engine technology potential. Instant torque that comes from the electric motor can be expanded in range and duration using a combustion engine, which thus provides the basis of this system. Depending on the model, these engines put together an output of somewhere between 250 and 300 HP, while achieving up to 70 mpg. Subaru's symmetrical all-wheel drive system will allow for the seamless transfer of power for better stability and traction even during tough road conditions. This electric internal combustion combination has it all: efficiency with performance. As electrification of the global automotive industry progresses, new engine technology from Japan opens a whole new world of possibilities. This has indeed been a practical solution available for immediate deployment to reduce emissions, while maintaining any performance level acceptable to consumers. Focusing on carbon-neutral fuels puts Japanese automobile manufacturers ahead in the race for sustainable transportation. Such innovation may greatly appeal to consumers hesitating to convert to an all-electric vehicle due to range, time spent charging, and accessibility of charging infrastructure. With up to 250 horsepower, 500 miles, plus quick refueling times, there's no question that the new Japanese engine has everything for the mobility of the future. Indeed, it combines sustainability with the very real requirements of modern-day transportation needs. You won't believe what's coming next. Japan's automotive legacy is about to blow you away. Why Japan's automotive industry stands out. Japan's automotive industry is a global leader in innovation, reliability, and efficiency, with a long history of producing vehicles that combine cutting-edge technology with exceptional craftsmanship. Companies like Toyota, Honda, Subaru, and Mazda have set the global standard for quality and dependability, with their vehicles consistently performing well in markets around the world. The focus on long-term durability and efficient engineering has allowed Japanese automakers to create some of the most reliable vehicles in the industry, with models like the Toyota Camry, Honda Civic, and Subaru Outback regularly exceeding 200,000 miles. This emphasis on reliability has earned Japan a reputation for building vehicles that last, contributing significantly to its dominance in the automotive world. A key element that sets Japan's automotive industry apart is its pioneering role in hybrid technology. Toyota's Prius, introduced in 1997, was the world's first mass-produced hybrid vehicle and revolutionized the idea of eco-friendly transportation. With a combination of a gasoline engine and an electric motor, the Prius delivers 50 mpg on average, providing an environmentally friendly solution without sacrificing performance or convenience. The success of the Prius spurred a global movement towards hybrid and electric vehicles, and Toyota's commitment to hybrid technology has continued with models like the Corolla Hybrid and RAV4 Hybrid, further solidifying Japan's role as a leader in sustainable mobility. The uniqueness of Japan's automotive industry stems primarily from the fusion of traditional engineering principles with the completely newfangled technology. It's perhaps a mark of Japanese automakers' consistency in balancing the reliability and performance of conventional internal combustion engines while accepting innovative principles such as hybrid systems, Skyactiv X engines, and electric powertrains. An example of this is Mazda Skyactiv X, which has features of the traditional gasoline engine and innovative compression ignition, thus enhancing fuel efficiency and lowering emissions. Subaru's symmetrical all-wheel drive system perfects the distribution of power, concerning the traction and stability of a vehicle, especially during travel under adverse conditions. These innovations signify a continuous evolution within Japan's automakers towards meeting the dynamic needs of the consumer through time-tested engineering, coupled with new advancements. Japan's automobile industry has been instrumental to environmental sustainability efforts, with Toyota, Mazda, and Subaru leading the pack in making their cars more eco-friendly. Carbon-neutral fuels are being developed, and hybrid systems have been adopted to enable Japan to continue development towards the desired goal of a sustainable future transportation solution. Such progress allows for existing infrastructure integration into the success of this endeavor. Besides continuing investments in electrification and fuel efficiencies, such new technologies in use ensure competition among Japan's auto manufacturers in the global marketplace. With these elements working together as history, quality, innovation, and sustainability-based legacy brightens a future, the Japanese automotive industry will continue raising the bar for years to come. The new engine. Japan's new engine technology, developed by Toyota, Subaru, and Mazda, represents a revolutionary leap forward in automotive engineering. Unlike traditional internal combustion engines or fully electric vehicles, EVs, this new hybrid engine is designed to integrate seamlessly with carbon-neutral fuels, sustainable alternatives to gasoline and diesel that are produced from renewable sources or captured CO2. The hybrid system leverages both an electric motor and a combustion engine, allowing for instant torque and the extended range of a traditional engine. This combination results in a unique balance of performance, efficiency, and sustainability, with vehicles equipped with this engine offering up to 250 horsepower and fuel efficiency of up to 70 mpg. One of the standout features of this new engine technology is its impressive thermal efficiency, which surpasses traditional combustion engines. Prototypes of this engine are designed to achieve up to 45% thermal efficiency, significantly higher than the typical 25–30% in traditional internal combustion engines, offering better fuel economy and lower emissions. By improving thermal efficiency, this engine improves thermal efficiency, reducing energy loss during combustion and enhancing fuel economy, which helps lower emissions while maintaining the vehicle's overall performance. In combination with carbon-neutral fuels, the engine is designed to minimize emissions, making it a more sustainable option than traditional gasoline or diesel engines. This breakthrough makes the engine a crucial part of Japan's commitment to achieving carbon neutrality while maintaining high performance and convenience for consumers. This is a new development for the petrol engine. Electric drive units packaged together with the new petrol engine into the hybrid drive technology. With this hybrid drive technology integrated into the vehicle, the power delivery can be transferred between electric and combustion fuels driving at any time, according to the mode that is best suited to the driving person. The combustion engine gets into action when the car needs more acceleration, or to maintain high speeds for a long time. The electric motor handles low-speed driving and boosts fuel economy. On a single filling of this fuel carbon-neutral fuel tank, a 500-mile range can be achieved, allowing long journeys without any requirement for pumping, which otherwise can be considered the major advantage of the conventional EV over charging stations. The hybrid system provides fast acceleration, with some models achieving 0 to 60 mph in under 7 seconds, making it competitive with high-performance vehicles while maintaining excellent fuel efficiency. This new engine is revolutionary because it can obviously use the existing infrastructure of fueling. Unlike fully electric vehicles, which require the establishment of a huge and costly network of charging stations, these vehicles can only be fueled at already existent gas stations worldwide. It takes as little time as 5 to 10 minutes for quick refueling, not much different from the case of normal gasoline-powered vehicles, and this would make quick stops available to drivers themselves. This does hold an answer to common range anxiety, which is typical among owners of EVs, but even further provides an answer that is scalable toward regions where the EV infrastructure is still in its infancy. Practicality handling traditional refueling puts the engine one step closer toward a viable and realistic alternative to battery-powered vehicles in the greener transport transition. Carbon neutrality. Carbon-neutral fuels are rapidly emerging as a transformative solution in the automotive industry, and Japan's automakers are leading the charge in this innovation. Unlike traditional fossil fuels, carbon-neutral fuels are produced from renewable resources or captured CO2, making them a key player in reducing global emissions. These fuels include biofuels made from organic matter, such as algae, and synthetic fuels created using renewable energy to convert carbon dioxide into usable fuel. When burned, these fuels emit only the carbon dioxide that was previously captured, achieving a net zero emissions effect. This ability to drastically reduce the carbon footprint of transportation makes carbon-neutral fuels a crucial part of achieving sustainability goals, especially in sectors where full electrification is not yet feasible, such as aviation and heavy-duty transport. The integration of carbon-neutral fuels with internal combustion engines provides significant advantages over traditional battery-powered electric vehicles, EVs. For one, carbon-neutral fuels have a much higher energy density than today's batteries, meaning vehicles can travel much farther on a single tank. While many electric vehicles offer ranges of 250 to 350 miles, vehicles powered by carbon-neutral fuels can achieve 500-mile ranges without the need for frequent refueling. Moreover, refueling a car powered by carbon-neutral fuel takes only 5 to 10 minutes, significantly reducing downtime compared to EVs, which can take 30 minutes to over an hour to charge, depending on the charging infrastructure. This makes carbon-neutral fuel vehicles far more convenient for long-distance travel, particularly in regions where charging infrastructure is limited or unreliable. Carbon-neutral fuels meet the energy density and refueling speed that batteries cannot match, while also addressing the challenges of EV production and infrastructure. The environmental and ethical costs of raw material extraction for EV batteries, such as lithium and cobalt, are quite large. Soil degradation, water contamination, and human rights abuses occur in countries from which these materials are obtained because of mining processes. Thus, Japan's new engine technology in carbon-neutral fuels would avoid such challenges because of large-scale battery production. With its accompanying environmental tariffs, the offer provides scalability of EV substitute that does not depend on the net growth of the global charging network, providing an immediate response to reductions in emissions without the massive infrastructural investment associated with fully EVs. Carbon-neutral fuels also are among the most persuasive reasons for being revolutionary in the transportation sector. With all countries implementing stringent emissions regulations, carbon-neutral fuels claim to provide a path for using these existing refueling infrastructures to emit less. For example, life cycle emissions from algae biofuels can be up to 90% lower than fossil gasoline. This means less dramatics in alteration of infrastructure, which makes them suitable to be used by automakers while attaining global sustainability goals. Japan's commitment to developing carbon-neutral fuel technology runs parallel to the international call for targeting carbon neutrality by 2050 in an efficient, scalable, and less expensive manner to reduce emissions in the transport sector, while still ensuring convenience and performance from cons. Compatibility with existing infrastructure. One of the most significant advantages of Japan's new engine technology is its seamless compatibility with existing refueling infrastructure. Unlike fully electric vehicles, EVs, that require a massive expansion of charging stations, vehicles powered by Japan's carbon-neutral fuel engines can be refueled at existing gas stations. This drastically reduces the need for new infrastructure and offers a practical, cost-effective solution for transitioning to cleaner transportation. Since refueling takes only 5 to 10 minutes, drivers can quickly resume their journey without the long wait times associated with EV charging, which can range from 30 minutes to over an hour, depending on the charging speed and availability of fast chargers. The ability to use established fuel networks makes these vehicles immediately scalable, especially in regions where EV infrastructure remains underdeveloped. The convenience of carbon-neutral fuel vehicles also extends to their range. While many EVs offer a range of 250 to 350 miles per charge, vehicles powered by these new engines can travel up to 500 miles on a single tank of fuel. This extended range alleviates one of the most common concerns about EVs: range anxiety, or the fear of running out of power before reaching a charging station. By combining long-range capabilities with fast refueling times, Japan's new engine technology offers a compelling alternative for consumers who need the flexibility and convenience of a traditional gasoline-powered vehicle, but with a much lower environmental impact. This makes carbon-neutral fuel vehicles ideal for long-distance travel, particularly in regions where EV charging stations are not as prevalent. Meanwhile, however, the electric vehicle market still faces challenges in terms of infrastructure. One of the biggest impediments to EV adoption has been widespread and reliable charging stations. Fast charging stations may not be conveniently available in even developed markets. Charging times may prove a deterrent for a consumer, such as the fact that charging at home could take about 8 to 12 hours for a full charge, and that fast chargers may take 30 minutes or more to charge. A lack of charging infrastructure will often include less convenient charging locations, primarily in rural or less developed areas, making EVs seem impractical for many consumers. With this new engine technology, Japan can address these issues by providing people a different alternative that utilizes existing fuel networks, avoiding all these extensive and costly time-changing infrastructure improvements. Carbon-neutral fuel vehicles are thus easier to introduce into the consumers as well as automakers when existing infrastructures are used. Refueling is done at known gas stations, with no expectation of involving special charging stations or equipment, as entry barriers become lower. Almost all these vehicles are going to have at least 250 horsepower and speeds up to 125 mph, the sort of performance that users come to expect from their traditional gasoline engines. Therefore, these vehicles would have most of what makes people purchase cars' fuel efficiency up to 70 mpg, and it would be a compelling option for those drivers who want it all. Environmentally friendly, but not compromising on convenience or power. Its compatibility with established systems ensures that the new engine technology of Japan will act rapidly toward the scaling among markets, and will thus help in being an economically viable solution in reducing emissions and improving the sustainability of transportation worldwide. Hold on tight, what's coming next could shake the very foundation of the EV industry. The EV industry's major challenges. Japan's push towards electric vehicles, EVs, is facing the same global environmental and ethical concerns surrounding battery production, but with a unique perspective and response. As EVs rely heavily on lithium-ion batteries, the extraction of raw materials like lithium, cobalt, and nickel presents environmental challenges. These materials are often mined in ways that lead to soil degradation, deforestation, and water contamination. Moreover, the mining of cobalt, especially from the Democratic Republic of Congo, has raised significant ethical concerns, such as child labor and unsafe working conditions. Japan's automakers are aware of these issues and are developing alternative solutions, such as hybrid and carbon-neutral fuel technologies, which can reduce the need for vast quantities of these rare and problematic materials. By focusing on carbon-neutral fuels, Japan's automakers aim to bypass some of these challenges while still working towards reducing emissions. The rising costs of raw materials like lithium and cobalt are particularly concerning in Japan, where automakers are working to balance affordability with sustainability. As demand for EVs increases, the cost of these critical raw materials continues to rise. In Japan, where companies like Toyota, Subaru, and Mazda are at the forefront of innovation, the need to source raw materials sustainably becomes a financial burden. Battery costs can account for as much as 30 or 40% of an EV's price, pushing automakers to look for alternatives. Japan's efforts to develop carbon-neutral fuel engines provide an alternative path, allowing automakers to reduce reliance on expensive raw materials for batteries while maintaining strong environmental goals. This approach could ultimately lower production costs and allow for more affordable EVs, especially in emerging markets where cost remains a significant barrier. Scalability is as important as infrastructure readiness, because the EV industry in Japan has remained largely challenged by that. Japan has made giant strides regarding the installation of charging stations for EVs, and yet still, they are few compared to the number of gas stations. At fast chargers, charging an EV in Japan takes anywhere between 30 minutes to an hour, depending on battery size and infrastructure. Under normal circumstances, EVs in Japan are expected to give an average range of 250–350 miles on a single charge, which indeed has improved, but has still left a range-anxious traveler. Most importantly, all of this is happening because the Japanese automobile companies are considering hybrid systems coupled with carbon-neutral fuels, which can be filled at gas stations, reducing drastically the need for the hitherto true last-mile charging infrastructure, thereby making the transition to a cleaner fleet more possible and scalable. Less of the ever-increasing network of charging stations would have to be built, and thus the transition to cleaner vehicles would also be more feasible and scalable, as it makes use of already existing infrastructure rather than needing new upgrades. In fact, given the above, hybrid and carbon-neutral fuel technologies spearheaded by Japan present ample solutions to the problem. While the world's EV infrastructures still need a lot of expansion, Japanese automakers are already de-emphasizing their heavy investment on expensive raw materials and highlighting the environmental concerns by introducing cutting-edge alternatives. Builds among several others, such as Toyota's hybrid technology, Subaru's electric motor integration, and Mazda's biofuel focus, show that Japan is developing a more sustainable yet scalable automotive future while bypassing some issues that strictly electric vehicles tend to face. Such innovations not only help the country in manufacturing, but also promote global emissions reductions and sustainability in transportation. Japan's strategic collaboration. Japan's automotive giants, Toyota, Subaru, and Mazda, are strategically collaborating to tackle some of the most pressing challenges in the global automotive industry, including electrification, sustainability, and the need for cleaner transportation solutions. This collaboration brings together the strengths of each automaker, creating a unified approach to developing innovative technologies. For example, Toyota's expertise in hybrid systems, Mazda's SkyActiv-X technology for higher fuel efficiency, and Subaru's leadership in all-wheel drive systems combine to create an engine platform that integrates carbon-neutral fuels and hybrid powertrains. By pooling resources and research capabilities, these companies are able to reduce the financial burden of developing new technologies, speed up the innovation process, and bring advanced solutions to the market faster than if they were working independently. The collaboration between these automakers also allows them to share the risks and costs associated with research and development. Developing next-generation technologies such as hybrid engines and carbon-neutral fuels requires significant investment, and by working together, Toyota, Subaru, and Mazda can reduce these financial risks. They can optimize the design and production processes, share the cost of innovation, and pass on the savings to consumers. This approach not only makes these technologies more affordable, but also ensures that the vehicles powered by these engines are competitively priced, allowing them to reach a broader market. In a highly competitive industry, this collaboration helps these Japanese automakers stay ahead of the curve and maintain their leadership in sustainable transportation. Collaboration with government policies and subsidies has shaped this involvement remarkably. Japan has historically been integrating the automobile industry through incentives and regulations to encourage the creation of green technologies. Such subsidies lower the costs of research and development of carbon-neutral fuels and hybrid systems, relevant to the country's longer-term vision to be carbon-free by 2050. The Japanese government also financially supports all projects targeting renewable energy infrastructures. All this encourages further partnerships between Toyota, Subaru, and Mazda to make innovations scalable and effective. With these joint ventures, Toyota, Subaru, and Mazda are going to shape the future of mobility according to a sustainable and performance-based concept. This partnership is a testament to Japan's intentions to become a world leader in green technology and sustainable transportation. In a world that is constantly finding ways to cut down carbon emissions, these Japanese automakers are setting themselves up to provide important solutions that combine traditional engineering with breakthrough innovations. This will also keep Japan relevant in the international automotive market that is still setting a trend of introducing more sustainable vehicles. The global ripple effect. Japan's new engine technology, developed by Toyota, Subaru, and Mazda, has the potential to create a significant ripple effect in the global automotive market, especially within the electric vehicle (EV) industry. While EVs have gained traction as a sustainable solution to reduce carbon emissions, the need for a complete overhaul of infrastructure, including charging stations, has been a major challenge. The new hybrid engine system, which runs on carbon-neutral fuels and integrates seamlessly with existing gas stations, offers a practical and scalable alternative. With 500-mile ranges, up to 250 horsepower, and refueling times of just 5 to 10 minutes, this technology could make the transition to greener transportation more accessible, especially in regions where EV infrastructure is lacking or not yet fully developed. For global EV manufacturers like Tesla and BYD, Japan's advancements in hybrid and carbon-neutral fuel technology pose a serious challenge. Tesla, which has built its brand around fully electric vehicles, faces significant competition as the demand for EVs increases. The reliance on raw materials such as lithium and cobalt for EV batteries is driving up production costs, which may make electric vehicles less affordable for consumers in the future. Japan's new engine technology, with its ability to use carbon-neutral fuels, helps reduce the dependence on these materials, offering a more sustainable and cost-effective solution. This could force EV manufacturers to reconsider their strategies and integrate alternative fuel solutions into their vehicles to stay competitive in the market. Hybrid technology and fuel power neutral technology developed in Japan could be viewed as going a step further in relation to current events about clean transport, conveniently accommodated for emerging markets where charging infrastructure for EVs is still very thin. As far as developing regions like Southeast Asia, Africa, and parts of Latin America are concerned, establishing the EV charging stations would be an uphill task because of the high cost implications involved in developing such infrastructures. Readily available in existing gas stations, such technologies from Japan would leave such markets with a better alternative. Cost-effective since consumers can easily access the technology without needing charging. Vehicles powered through this carbon-neutral fuel source, moreover, can reach maximum speeds of 125 mph and an acceleration from 0 to 60 mph of less than 7 seconds, making them efficient but competitive on performance against battery-powered EVs. This can further increase the global dimensions of new technology and hence contribute to establishing a strong foothold for Japan on the mosaic of nations as one dedicated to sustainable transport. As many governments around the world now gear efforts toward reducing carbon emissions in their nations, achieving carbon neutrality by 2050, a comprehensive solution with scalability and practicality from Japan, as per carbon-neutral fuel and hybrid engine technologies, has become enticing for consumers and public policymakers. Integration of such engines with existing networks for refueling further would bring benefits by increasing efficiency in fuel economy and performance, as high as 70 pence mpg, assuring the automotive industry of Japan strong leverage in the global shift towards sustainable mobility. Challenges and criticism. Despite the promising features of Japan's new hybrid and carbon-neutral fuel engine technology, several challenges and criticisms surround its long-term viability and scalability. One of the major concerns is whether the infrastructure required for producing and distributing carbon-neutral fuels can be expanded rapidly enough to meet growing demand. While these fuels offer a promising alternative to traditional gasoline, widespread availability is crucial for mass adoption. Additionally, the production process of carbon-neutral fuels requires significant energy inputs, which could raise concerns about their overall carbon footprint, even though they are considered more sustainable than fossil fuels. Furthermore, the cost of producing these advanced engines may remain high until mass production becomes feasible, potentially limiting their affordability for consumers and hindering their broader adoption. Another area of concern is how Japan's new technology compares to existing alternatives, such as fully battery-powered electric vehicles, EVs, and hydrogen fuel cell vehicles. EV proponents argue that electric power is the future of transportation, with Tesla leading the charge in the global EV market. EVs, powered by lithium-ion batteries, offer zero-emissions operation and benefit from an expanding charging infrastructure. Hydrogen-powered vehicles, such as those produced by Toyota and Honda, also promise fast refueling and long ranges, similar to conventional vehicles. Critics of the carbon-neutral fuel engine technology argue that, while it may provide a more immediate solution, it might not be as sustainable in the long term as fully electric or hydrogen-powered vehicles, particularly if it continues to rely on fossil fuel-based infrastructure for its production and distribution. Another main barrier to the implementation of the new engine technology in Japan is regulatory approval. Countries across the globe have been tightening up emission standards and stricter guidelines to ameliorate any carbon footprints offset by the movement of vehicles. Unlike other carbon-neutral fuels, they are, at the moment, planned to pollute less than conventional gasoline. Production emissions might not be exempt from costs, as many areas will tend to be inclined to impose that cost for acceptance in regions with very strong environmental regulations, particularly the European Union. After overcoming the toughest challenges, this last chapter will shatter all limits. The future of mobility. The future of mobility is focusing heavily on sustainability and reducing transportation's environmental impact, and Japan's new hybrid engine technology is a major step in this direction. Unlike fully electric vehicles, EVs, which still face infrastructure and battery production challenges, Japan's engine technology can be seamlessly integrated into existing refueling networks like gas stations. This eliminates the need for a massive infrastructure overhaul, offering a more practical solution for a quick transition away from fossil fuels. With global demand for lower emissions increasing, Japan's approach allows for sustainable transportation without compromising on the performance and convenience drivers expect, offering 500-mile ranges and up to 250 horsepower for a balance of power and efficiency. Japan's hybrid and carbon-neutral fuel-powered engines provide a flexible solution that complements other sustainable technologies like EVs. While EVs are an essential part of the future, the global automotive industry needs a variety of options to meet stricter emission standards and carbon neutrality goals. Japan's new engine technology offers an alternative for regions where EV charging infrastructure is sparse or expensive, enabling the use of existing gas stations for refueling. This scalability allows for a quicker, more accessible transition to sustainable vehicles, without waiting for widespread EV charging networks to be established, making it a more immediately available option for consumers and governments alike. The use of biofuels, synthetic fuels, and carbon-neutral alternatives as fuels ensures diversity in the transportation sector for Japan's strategy on engines. Renewable energy or captured CO2 can produce these fuels at low carbon and energy density similar to conventional gasoline, enabling integration into existing energy systems. Integrated electric, hybrid, and carbon-neutral fuel technologies ensure a front-row seat in sustainable transportation in Japan, and also offer a practical decarbonization option that does not rely only on electric power. Thanks for watching. If you enjoyed the content, don't forget to hit the like button, leave a comment, and subscribe for more. Be sure to watch the next video popping up on your screen. There's plenty more to discover. See you in the next one.